Hello, everybody. Welcome to the CCI broadcast today for the MSc, which I run. I am Phoenix Perry. You can find all about me on the internet. I am Phoenix Perry everywhere. You can find me. If you're interested in our MSc, I have a really cool thing for you today. Rebecca Fiebrink, who is my longtime collaborator and dear friend, is here to talk to us about machine learning. And she was the very first person who taught me anything about machine learning back in like 2008, 2009. And it took me a really long time to understand how radical what she was doing was. And it empowered me to use my body to create interfaces in a way that was accessible for me. And we're going to talk a little bit about that today. And we're also going to talk a little bit about what the MSc is. I have a really good news for you. A brand new video is about to come out. It's not finished. This is a special preview. My name is misspelled in the credits, which, we're just not going to talk about it. It's just not happening. But I'm going to show it to you, and you're going to get to see how I collaborate with students at the CCI. So, Tom, if you don't mind, let's watch the video of Forced Daydream.
We play as creatures in this world. We play to test our limits. We play to see how things fit. We often experiment in play and try things out in play that we wouldn't feel safe doing if the context was removed.
It's really an attitude with which you engage in the world. By playing, you can create something new, or you experience something that you didn't expect.
Hello, I am Phoenix Perry, and I'm the course leader here on the Creative Computing degree at the Creative Computing Institute. This is a project called Forced Daydream, which is the third iteration of a project that I've been working on for several years with many different collaborators. It is a long-term research agenda that I've had to look at social play in groups and collaboration in groups. So the project itself involves a couple of pieces. There is a small forest, which looks like a low poly video game forest, and a small hut, which looks like a low poly video game hut. My thinking behind that is that we spend a lot of time in virtual natural environments when we live in cities. So pulling where we actually end up going back out into the real world and looking at it as an object. So that's why it looks the way it does and the kind of architecture it has. Beyond that, each piece is interactive, and then there are games which play out amongst the pieces, and they require multiple people to play. So something will be happening over here, and then you'll need a response to it over here. So there's no way to play it on your own, so you have to ask for help and ask for cooperation, which is one of the underlying philosophical points I'm trying to make in the game, is that you can't do things on your own, you need to do them in groups. We have this class here that I'm leading right now on environmental computing and spatial computing. They are working with me on this project in an attempt to get experience working with a gallery, with a large-scale institution like Wellcome Collection. So it's part of the pedagogical process of getting them from point A to point B, of being ready and able to work with the public and knowing what that looks like. Then from there, they're going to proceed to doing full-scale works all on their own in public spaces.
Personally, I was rather focused on the programming of the microcontrollers. All the different parts have to interact with each other, have to talk with each other. So every button press has to be signaled somewhere else, and all the different parts have to be coordinated into one single game.
You've got sounds going on and lighting and all these physical models. So these really create an environment. I hope people coming would feel relaxed.
I worked on the soldering and the wiring, and I also helped with the construction of the dome and the trees. you are not designed for yourself. So you need to study how others behave and interact.
My name's Ben Kelly. My role in Forest Daydream, it was almost like a sound supervisor role to create an immersive soundscapes which evoke the rainforest, and also music composition. Los Casinos is an ongoing project with the Wampi, the indigenous community who live near the Ecuadorian border of the Amazonas rainforest. I spent some time with them 2 years ago and developed an ongoing relationship as an artist to help with their government, to help deforestation and indigenous land rights. The sound recordings, the soundscapes are very immersive, as again a hyper reality, to try and aim to trigger this emotional feeling, this primal feeling of interconnectivity with nature. I hope it stimulates audience members to ask themselves questions of their own role within the social ecological system.
We need outlets for social collaboration and communication as adults, and we don't get them enough. And we really have to think about how play sits in a modern society in new ways.
Cool, welcome back. That is the project that I built with our MSc students this last term before COVID. We'll never see that project out of a box again. We'll see what happens. But it was a really amazing experience to collaborate with our students and really explore the area of play and environment and social collaboration, which has become incredibly interesting during the time of COVID. Actually, what ended up happening in the class is everybody made online multiplayer experiences to explore that same idea. And it was a really profound change for us. That said, I now want to introduce Rebecca Fiebrink, who's going to talk a little bit about machine learning, and she teaches on this MSc. Everything she's going to talk about is the kind of thing that you can learn during your time here at CCI. So, hello, Rebecca Fiebrink, take it away.
Hi, Phoenix. Thanks for that. So I've prepared a little bit of a talk to get people an intro into the kind of work that I've been doing in my own research for the last 10 years or so, get a taste of some of the things that I'm going to be teaching on the MSc, and also seed the discussion that Phoenix and I are going to have in a few minutes about, what machine learning offers to creative practitioners, how we engage with this both as instructors and researchers and creative folks ourselves, and then some other thoughts about the bigger picture around machine learning in the world right now. So I've got some stuff to show you. You should hopefully, there you go, see couple pictures here. When I tell people that I work with creative machine learning, often they have a couple misconceptions. Either people think that I'm making some kind of Terminator style AI system that is going to take the place of human creators in art or music or whatever and get rid of all the jobs. And that's really, not something I'm interested in, and frankly, not something that I think is particularly likely either. Or in the last 5-6 years, people have thought, oh, you're doing deep dream, or you're doing some kind of machine learning that autonomously generates art with its own style. And that's not what I do in my personal research either. I think some of that work is super interesting, and there's a lot of interesting creative possibilities in the realm of what machine learning algorithms can do when they generate art, or whatever you want to mean by that. But my interest is much more related to how we can use algorithms paired with human creators. And so here's a picture of my friend Dan. And my friend Dan is a musician and a composer and works with technology in his work. And often when I think about the role of technology or machine learning more specifically, I think about Dan here in his home studio. And I think about how he is using the computer right here. He's not making art or music about computers. The computer here is sort of in the background. It's doing some of the things that he maybe would rather not do as a person, like, notate music for 10 different instruments and then print out those parts, right? That's just not a good use of his time. He uses a computer to do that. He also uses a computer to do things more effectively that allow him to, say, explore different alternatives in a composition. He can change the notes that he's written very, very quickly in some notation software and decide right away whether that's a change that he likes or not. So in part, what I think about is how machine learning or other types of technology could function like this computer in the background. But I also think about Dan's violin. Dan is an expert violinist. He composes often with his violin in his hand or with another instrument in his hand if he's writing for something else. And I think about technology, including machine learning technology, often as functioning like an instrument, like something that we can be intimately familiar with, that we can interact with not just by sitting back and rationalizing, but by thinking with our bodies, by putting feeling into it, by bringing embodied expertise into it, and bringing in practice that we don't necessarily associate with computer. So again, I'm interested in this question: how might machine learning act like a violin, like something that you pick up and work with as not necessarily even a creative partner like you would with another person, but a creative starting point that allows you to explore totally new places, new sonic possibilities or new artistic possibilities that wouldn't be possible if you didn't have that violin or the equivalent there. So that's really the starting point for a lot of my own research in creative technology. And when I started using machine learning about 12, 13 years ago now, my interest in this field came largely from the fact that we had lots and lots of sources of data that we could use as creators making new kinds of music or games or interactive art, or any number of other things, right? The Microsoft Kinect came out around that time. The Nintendo Wiimote came out. We were just getting smartphones that had sensors in them for everything from GPS to movement data. And since then, of course, we've got hardware like the Leap Motion, hardware systems like Arduino that have made a lot of types of sensing more accessible in many ways. But if you are a computer scientist, if you're an engineer, if you're an expert programmer and hardware developer, that's awesome, but you'll still know that getting data and from these things might be easy, but interpreting it, saying something meaningful about it, is often really difficult and annoying. And if you're not a computer scientist, you're not a hardware engineer, then this can be even more the case, right? Taking some data from motion sensors on your phone or from sensors plugged into an Arduino or from, sound coming into a microphone and saying, "Oh, I can say something about what a performer is doing or what somebody who's come into an art installation space is doing." Good luck. You can do it, but it's often a lot of work and it's really error prone and really difficult. And I came into this space having studied machine learning as a computer scientist, and thinking about machine learning in what we would call more conventional applications of data analysis, where you have lots and lots of data and you can make interpreting that data easier using machine learning. And so I've got a few slides here that were my starting point for thinking about, hey, machine learning might help these people building new musical instruments or art installations or games and so on, working with these sensors. And the key here, I'm not going to go into detail about how any of these algorithms work because that's actually not important. But the key here is to understand the kind of interaction that this enables you. So instead of saying, all right, I'm going to sit down, I'm going to write a program that looks at, say, pixels from my webcam and analyzes those pixels in order to say, oh, somebody's holding up their hand and there's a closed fist, right? Instead of doing that, I'm just going to give the computer examples of a closed fist and tell it, hey, that's a closed fist. And when you see that, maybe I want to make this particular sound if I'm building a gestural instrument. Or maybe I want to make my game avatar jump if I'm making a video game. And maybe alternatively, I want to have it do something else, make a different sound or game action when I show it an open hand. And again, there I just give some examples of an open hand, give those examples to a machine learning algorithm, and I have a reasonable hope that we are going to be able to trigger different sounds or game actions with different hand gestures. And there's several variations on this, right? I don't necessarily need to just pick whether I'm making one sound or another. I could do more interesting continuous control. So, for instance, I could say, well, I've got a dancer moving, and or I've got somebody who wants to play really expressive, interesting, complicated sounds, not just choosing one recording or another. And so I might give examples like, all right, when a person moves over time and we sense that with a camera or another sensor, maybe we've got a bunch of parameters that we want to change in our music or our game, and I want those to change in a particular complicated way. All right, so that's the basic idea. And when I started becoming interested in this in around 2008, 2009, I built a piece of software that would allow people to make these examples, give them to a machine learning algorithm, and then deploy that machine learning system so that as they moved or did other things in real time, you could have sound or game or something else changing in response. And that piece of software is called the Wekinator. It's still around. I've rebuilt it a couple times since those early experiments. Became my PhD work at Princeton, and it's become a platform that I use a lot, not only for my own creative practice, but for teaching, for other research about creative machine learning, and other projects that I'll mention in a bit. So with that, I want to pause talking about this, and I've got a demo video to show you to illustrate, if you haven't seen this before, how easy it can be to build some real-time interactions using this type of machine learning. So here we go. I'm gonna play this video now. All right, in this demo, I'm going to build a very simple gesture-controlled drum machine using Wekinator. And as my input device to capture information about gesture, I'm going to use my webcam. And I've got a little program here, which I like to call the world's worst computer vision feature extractor. What I'm doing is just taking those pixels coming in from the webcam and downsampling that to a 10 by 10 grid of color values. You can't hear the sound?
And this gives me 100 numbers, and these numbers are going to change as I move in front of the camera, as you see. But even if you're an amazing programmer, I would guess that you would not want the job of writing the program that looks at these 100 values and says something useful about what I am doing in front of the camera. So instead, we're going to use machine learning to make sense of these 100 values and make pretty accurate predictions about what kinds of gestures or motions I'm doing. All right, so I'm going to have Wekinator here listen to 100 values from this camera program, and I'm going to build a classifier, which is going to, again, predict what type of action am I doing at the moment. And we're not going to load a training set from somewhere else. We're actually going to build this training set right from scratch in the demo. And I want to, not just have Wekinator output a number. I want to have this control a sound and make this a little bit fun, right? We're going to control a drum machine, like I said. So I'm going to run a very simple drum machine program written in Chuck. And when I send this drum machine different numbers, we're going to hear different sounds, just like this. All right, so let's start out. Let's give it some training examples. And I'm going to say that when I am right here in front of the camera, I want to hear this simple sound. So I've got 17 snapshots of me here paired with this sound. And next I'm going to tell it that when I'm not in front of the camera, turn that down so you can hear. When I'm not in front of the camera, when I'm out of frame, I want to play a different sound, specifically this one. Let's go. Okay, now I've trained, I've built my model. Let's run this model and see what happens. Okay, it's pretty good. It's definitely changing between the two sounds, more or less the way I'd like it to. However, it's being a little bit too eager to change to that second sound, even when I'm not totally out of frame yet. So I'm going to give it some more training examples to try to fix that error.
and say that when I'm right here, actually, I still want to hear the first sound. And now I'll retrain, I'll rebuild that model, and we'll see if it works any better. And in fact, that's pretty good. I can keep moving around and see if I can make it make other mistakes, like right here. I can, oops, forget I did that. Let's give this as sound 1 and say that I want sound 1 over here. And I can retrain and keep running and see that, yes, it's doing what I'd like. And once I'm happy with that, maybe I want to make it more complicated. I could give it another sound with, say, my hand in front of the camera, like this. Okay, there we go. That is a pretty easy way of using Wekinator to make a classifier where I'm controlling a few different sounds based on simple movements of my body. All right, so I'm going to switch to a second demo since Tom is telling me that the video seems good enough to keep going. So this is, I'll let my video self introduce what you're going to see next. Controlled drum machine using Wekinator, and as my input device to capture information about gesture, I'm going to use my webcam. And I've got sorry that this is the right video. All right, so that demo I just showed you was pretty fun. You can imagine that, you know, for an audience, watching somebody move on the stage is probably more interesting than watching them just change sound by clicking a mouse button. And in the hands of a good choreographer, you can imagine something that becomes really visually compelling as well as sonically interesting. But when professional composers have used Wekinator, they're using it in a slightly different way, often to exploit the fact that you can use machine learning to build very different types of instruments. The sounds that you heard in the previous instrument were the same sounds that I could easily make by just pressing a few buttons to switch between different sound options. But sound becomes a lot more fun to many electronic composers when you can explore a really big space of sounds, when you've got a large palette to draw from and you can come up with ways of playing sound that are much more nuanced, much more complex, more exciting than just, you know, switching between a few different presets. So in this demo, I'm going to show you how you can use Wekinator with regression to do exactly that. And the instrument we're going to play is going to control a sound synthesis algorithm called Blotar. And Blotar is fun because it has a lot of different sounds that it's capable of making. So here's just a few of the Blotar sounds. Okay, and for each of these sounds, I'm getting that sound by giving Blotar a different set of control parameters. Specifically, I'm changing 9 of its control parameters. So you can think of each of those sounds as a point in a 9-dimensional space. And I'm going to build a Blotar instrument where I control these sounds using this. This is a game track controller from an old PlayStation game called Real World Golf. But we're just going to use it as essentially a 6-axis joystick. I get X, Y, and length of each of these 2 strings that I pull out of the bass here. And so I'm going to tell Wekinator I want to take these 6 input values and use them to control those 9 Blotar parameters. And I'm going to use regression so I get smooth changes. And of course, this is, again, something that would be really hard to do even for someone who's an expert programmer, because not only are you trying to find good positions in this 9-dimensional space, but you're trying to come up with a mapping function that says how the motions that somebody's doing here move you through that space in a way that's not only musically interesting, but maybe gesturally comfortable, where the gestural mapping might be easy to learn or easy to execute certain gestures that give you sonic gestures, and so on. So that's very hard to think about as a programmer. It's a complex function to write, but here we can do it pretty easily with machine learning. So I'm going to start out by finding a sound that I want to put in the blowtar. And maybe I want that sound, and I'm just going to put it over here pretty comfortably. Record some examples, and maybe another sound higher in pitch, say over here. You can record some examples here, and just training from these, you understand what's going to start happening. Okay, so I've got smooth change, and it's learned that lower pitch is over here, higher pitch is over here. That's fine, not too interesting yet. Let's start to add more sounds in and see what happens. Put this sound over here. Should mention this is taking a little bit longer than usual to train because I'm running my video capture software at the same time. Okay, so hopefully you saw some interesting stuff happening there. Not only was it giving me access roughly to the sounds that I put in the training set, and still having this behavior that when my hand was kind of back here, I was getting a low to high pitch relationship, but it was also giving me all sorts of other sounds as I moved between these very, very different timbres, which I'd put in different parts of my gesture space. I was getting sounds that I didn't put in the training set that I have never heard before, even though I do this demo quite frequently. And this means that I can start gesturally exploring the space of this synthesis algorithm. And of course, I can use machine learning to refine this instrument or this mapping that I've created. If I like a sound somewhere, I say, oh, that's a really cool sound and I like it where it is. I can add more training examples of that pair to reinforce that behavior. Or if I don't like a sound somewhere, I say, oh, that's silly, that's silent, or that's just really stupid sounding. I can put a different sound in that part of the gesture space and retrain it, and I'll get a different instrument. And I can keep refining my instrument in this way until I'm happy with it. Then I can save the whole thing and run it, the models as they are during performance. All right, so I'm going to stop that there and talk a little bit about what has happened since I made that piece of software. So Wekinator has been downloaded about 25,000 times last time I checked. It's been used in a lot of different kinds of creative projects. Initially, I was making and refining the software with composers, and certainly there have been a lot of people making music with it, including Letitia Tsunami. If you're interested in music, I highly recommend checking out a paper that she and I just wrote together about how her use of machine learning in Wekinator over the last 8 years has influenced the way that she builds instruments and composes music. Wekinator has also been used by Alex Murray Leslie of Chicks on Speed to make some really weird foot-controlled instruments, and then it's been used in all sorts of other weird, interesting projects. So this here is one of my recent favorites. This is somebody on the top right here made an interactive shadow puppet system where depending on what shadow puppet characters you raise up, you will get a new background for those characters to play around in. We've been using it in a number of research projects with people with disabilities to make more accessible musical controllers. I've been using it in teaching workshops all around the world in the last few years, and so on. So just to give you a couple other highlights, yeah, this is one of my favorite artistic projects. So this is a project where you wear a camera on top of your head, and it looks for anything that Wekinator has decided is a screen. So if you have a phone or a television or a computer in your field of view recognized by Wekinator, it takes your glasses and it turns them opaque. So you're unable to look at screens while wearing this art project. This is a little project by an undergrad student of mine a couple years ago. This is by Isabella Mond, and this is a magic spell game. So as you play this game, you have to cast different spells by drawing different shapes on the screen. So as you go through this game, you have to choose a spell, and then Wekinator is used to recognize which spell you have cast. And of course, you have to cast it with some care in order for it to be recognized correctly. This is another really fun project a student in one of my workshops made. This is Highbot. And if you wave at Highbot, Wekinator senses your wave using a leap motion, and there's a little Arduino with a servo motor, and Highbot will wave back to you. So that's kind of a cute thing. As I mentioned, I've used Wekinator and then projects built on top of it for a number of more serious research projects. One of the more recent ones is called Sound Control, and this was a collaboration with some music teachers and music therapists who wanted to build originally musical instruments for kids with a variety of disabilities. And as this project evolved, we made a totally different piece of software that encapsulates not only the machine learning, but support for a lot of off-the-shelf hardware devices and a lot of music making modalities. And as these music therapists and teachers and kids started using it, they found out all sorts of other things that they could do with it. So not just making an instrument for somebody to perform with, but making on-the-fly sort of collaborative jamming systems, or on-the-fly sonic games where you could hide the sound of a dog barking somewhere in the space of gestures and the kid would have to look for it, and so on. And so that's another free project. Both Wekinator and Sound Control are open source software that you can just download and play with. And Sound Control might be a fun place to start out with if you have kids or know people with kids who might want to play with this stuff to make music. As a researcher, a lot of the papers that I've written stemming from Wekinator are not so much about the technical aspects of machine learning, but really reflecting on how this approach to building things can be better than the approach of just sitting down and writing code. Or if not better, what kinds of other possibilities this approach can give you. By the way, this is a picture of another really fun musical instrument that somebody built with Wekinator, where you cast shadows on a piece of tree bark, and that changes the sound. And just to run through these with you, these might be things that Phoenix and I talk about it in a few minutes, but they're super important. So for one thing, building anything by example rather than programming often means it's just faster to build something. And changing things by changing examples rather than debugging or editing your code also means that it can be faster to explore different possibilities. And if you've ever built anything, whether that's a piece of art or a piece of software, you know that rapid prototyping and iterative refinement are really key to enabling you to not only make something quickly, but to make the right thing, to end up converging on an idea that's your best embodiment of the project you want to be doing. Also, something that came out of this work is that machine learning can enable more complex relationships between humans and machines. And in a musical or art making or physical computing context, this often means that, when you're programming, it's really easy to make something that, say, makes a sound or creates a response when you push a button, right? That's easy to program, and that means that lots of people make stuff that, you interact with by pushing a button. But actually, we do all sorts of other things in our real lives as people with bodies, and these are hard to work with as programmers. It's hard to work with data coming into a webcam and say what gestures someone is making or what kinds of sounds someone is making. And if we use machine learning, we can start opening up new creative possibilities to say, all right, well, what might we want a computer to do in response? And related to that, again, I want to say a lot of the things that are important to us as people is to act as people in the world with bodies. And we have embodied ways of acting that we do with the objects around us. Why not make games or music with those types of actions rather than, twisting knobs or moving sliders around? And of course, even when we're talking to another person in our native language, it's really hard to describe in words how we might want to move, or how we might, move expressively to express some kind of feeling. It's much easier for us to communicate as people with each other using examples, using demonstrations of things. So machine learning allows us to communicate with machines using examples as well. Um, and there are a lot of possibilities that machine learning brings for serendipity. You saw in the second example video that I showed you, I was getting sounds that I'd never heard before, even though I was working with a music program that I use quite often. And machine learning is nice because often when it surprises you by giving you a different behavior or a different sound or different visualization than what you expect, rather than, say, giving you a segmentation fault, which is a surprise that you often get as a programmer. And then finally, of course, this type of approach to building things can be accessible to non-programmers. I've used Wekinator and sound control with kids as young as 6, and it's doable. It allows them to start making interactive art pieces. It allows them to start engaging with interesting questions about how you do good interaction design. And of course, that's true all the way up through adults who might be professional interaction designers or artists, but don't program and should have to program in order to make some really interesting stuff. All right, so finish this up with a few points about where my work has taken me recently. So I have been doing a lot of teaching about creative machine learning, both on the Cadenze platform, where I have a MOOC about machine learning for musicians and artists, and now on the Future Learn platform, where we have a course that just launched yesterday about creative machine learning. And not only do I think it's really important to teach this kind of stuff to a lot of people who might benefit from it in their creative work, but also to reflect on that teaching and use it to comment on and think about, how do we teach machine learning to creative people, to kids, to the general public? I don't think that the way that computer scientists teach machine learning is even necessarily that great for teaching computer scientists, much less everybody else. So as a researcher, I've got a strain of work which is around, hey, what should we be teaching to people in order to educate them appropriately about machine learning? What kinds of tools do we need to do that? What kinds of background knowledge should we draw on? And so on. I'm still really involved in making other tools, other platforms for people who might be musicians, artists, creatives, to use machine learning in different types of work. One of the biggest projects that I'm involved in is called Mimic. And if you go to mimicproject.com, you'll see a bunch of in-browser coding tools for working with machine learning, both the kinds of stuff that you saw in Wekinator, as well as generative machine learning, deep learning algorithms, and so on. And then finally with Phoenix, we've been working on a project called InteractML, which is a visual scripting environment for machine learning in Unity. So we'll talk about that in a bit. And I'll leave you with this last question that I've been musing about ever since we had the Cambridge Analytica scandal that broke a couple of years ago. I think most people's experience of machine learning right now, if they're a member of the general public, is one that is maybe frightening, certainly very disempowering. Often your experience of machine learning might be that you have a sense that data is being collected about you, it's being sent off somewhere else, and someone else is profiting from it, often immensely if you consider companies like Facebook and Google and so on. They're deriving a lot of value from your data, and it often feels like there's not much that you can do about it. So in my work, I'm interested both in educating people to feel like they have a voice, or they have a right to have a voice in the conversation about how we use machine learning, who uses it, on what data, but also starting to reimagine what machine learning could be, to say, you know what, there's all this other data that surrounds us that we generate in our everyday lives. What other value could we be getting out of it? What if everybody was better able to work with data in ways that benefited them, in ways that they really had control over? And so that's a question I hope we'll get to talk about with Phoenix now. So there we go. I'm gonna quit that and come back to Phoenix here.
Hey, everybody.
Hello.
Hey, we're back. So it's always really interesting for me to hear Rebecca talk about her work because it's so deeply tied to so many of the questions of being in the body and being in space that I experience in my own work. And I am excited to just have a conversation with her about our society and what's going on now and things that we both think about. So, the last thing you mentioned really struck me. I was wondering if you could talk a little bit about how bias creeps into machine learning online.
Yeah, so I'll start out by maybe giving a quick definition of bias because that's that's something a lot of people are talking about right now. Not everybody's talking about the same thing, and I think one of the very problematic ways that bias is happening in machine learning systems has to do with um, you, say creating machine learning algorithms whose outputs might reflect what we would call bias in human life. So racism, sexism, detrimental stereotypes about people. This is certainly not the only kind of bias, and we can talk about that if you want. But one of the things that commonly happens is that if we want to train a machine learning system that is a classifier, for instance. The first demo that I did with Wekinator was a classifier where it chose whether to play one drum loop or another drum loop or another drum loop, right? Um, an example, a very problematic example of classification that we have seen recently is around things like predictive policing, right? We don't necessarily need to use a classifier. We could formulate this problem slightly differently, but in the simplest case, we could say, well, based on all this data about where people have been arrested in the past for crimes, where do we think crimes are likely to happen in the future? And then it could, put a yes or no in front of your postal code. And of course, this is potentially really problematic because the history of where people have been arrested in the past is largely driven by where humans who have all sorts of biases about certain people or about certain types of crimes that they want to target and so on and so on. That data is coming from the real world. And if you've been, you know, targeting people for certain things in certain neighborhoods, the data is going to show that that's where you should go in the future if you want to make the same types of arrests. So that's one type of bias. Another type of bias is something we're seeing a lot in generative algorithms, which I haven't talked about. But a good example of this is in text. So we could train a generative algorithm on lots and lots and lots of text, maybe give it, 500 books, and then tell it, okay, you've seen something about how the English language tends to place one word after another over time. Now generate me some sentences. And researchers have been looking into some of the what I would call the state of the art algorithms for text generation and seeding them with sentences like, the man worked as, and then the algorithm completes the sentence. The woman worked as, and then the algorithm completes. Or the black person did blah, blah, blah. The white person did blah, blah, blah. And what you see, unsurprisingly, is that often the sentences that such an algorithm comes up with are quite problematic. It is going to say things like, and I'm not making this up, I tweeted about this a few weeks ago. There's an algorithm called GPT-2 that one of the sentence completions for a black person or the black man worked as was a pimp, and the white man worked as a police officer, right? Why is that? Well, that's because a lot of the training data comes from people who are writing in very different ways about black people, about white people, about men and women, and so on. So, um, a lot of the machine learning algorithms that are being developed and even deployed in the real world that have been trained on lots and lots of data are unsurprisingly going to reflect the patterns that are in those data. So, at the end of the day, it's number one important to know this, to know that algorithms are not going to, they're not anywhere near being able to save us from our own human biases, but what they are likely to do is actually replicate those biases often in ways that are might not be immediately obvious to us, but they're sort of cloaked in this myth of machine objectivity. So I could go on about that, but maybe you want to go somewhere else next.
Cool. All right. So let's go ahead and talk a little bit about small data, because you talked about big data and you talked about how big data is getting used to kind of amplify our biases. How could we think about using small data? And like, how could we think about using small data as maybe a way to queer this space or like take control back of our experiences with machine learning?
Yeah, so that's a great question. You'll notice, I think, in the demos that I showed with Wekinator, the number of examples that I was providing was super small. You can train Wekinator for certain problems on as few as like 4 or 5 examples, and at the very most, I think people using Wekinator might have hundreds or thousands, but typically not more than that. And that's super different from a lot of the deep learning systems that are out there, or generative systems for text generation, as I mentioned. And the way that we're using data in Wekinator, in sound control, in other work that I've done, including InteractML, is fundamentally different in that our goal is not necessarily to make a model of some huge data set that's out there in the world that we as people might not understand, or that we as people might not be able to describe accurately in a program or a mathematical equation, right? Often our goal instead is to communicate something to the computer about a design idea or about something that we ourselves are doing. Um, and so, I might make an activity tracker of myself, for instance. Maybe I want to know from, something that I wear on my body, what kinds of actions I'm involved in throughout the day. I could buy one of those off the shelf, and it's going to be trained for, to be pretty generally accurate across a lot of different people. Hopefully there's not too much bias in that data set, but of course there's going to be, if not bias in the data, there's going to be assumptions by the people who made that system about what sorts of things I find important, what sorts of, what does a normal walking look like, what does normal sleeping look like, and so on. And maybe that's fine for me, but maybe it's not. And as it turns out, that's not fine for me. I, spent the last year and a half being pregnant and then having a kid, and I'll tell you that, my bio signals were not normal at the end of pregnancy. My sleep is not normal right now, and that, the models that come prepackaged with my fitness tracker are totally useless. And I haven't worn the thing in months. But if I could train one myself and say, look, this is what sleep looks like for me at this moment, please, just classify all this weird stuff as sleep, because that's what I'm going to call sleep for the purposes of my life, that would be fine. And that's, one sort of conventional way that we might use personal data. And then on the weirder end of the spectrum is something like building that blowchart instrument, where it's not even about, analyzing correctly how I'm moving, but saying, you know what, I want to build a thing. I don't know a priori how I want to move, how I want to make this model. I just know that I want some cool sounds to happen. I want to move in a way that's comfortable for me. I want to move in a way that's maybe visually evocative in some way for my audience. And I'm going to provide a few starting examples that allow me to explore that space. And my examples are sort of, even a hypothetical, like what if, what might happen if I associate this movement with that sound and this movement with that sound. And then I build something with machine learning and I try it out. And then based on my playing with it, I might take it somewhere else. So I think both of those are under the umbrella of small data, where I might say, you know what, I'm going to invest time and effort into making something that models me really accurately, that does something that is meaningful to me, that doesn't involve normative assumptions that might not be appropriate for me. Or on the other hand, just to say, you know what, I'm using data as a way of communicating about embodied practice or tacit knowledge or other things to a computer to explore some kind of creative space.
Yeah, that was when I first started using Wekinator. The reason I first started using with using it was I wanted the ability to build musical interfaces as a musician without having to use a mouse and keyboard, which caused me a lot of pain on like a regular basis. So I thought that was like a really interesting situation and experience, and it really showed me the power of thinking about small data. And ironically, I went to an interview, and I was interviewing for this thing, and this guy was like, I see you work with machine learning. Do you work with big data? And I was like, I work with small data. And he's like, but big data. And I'm like, but small data.
Yeah.
And it was really interesting just to see the power. And he just unraveled. Like, it broke him to think about the fact that my data could be relevant just to me. Like, he
Yeah.
hated that.
Yeah.
It made him so angry. And I was like, get over yourself. Get over yourself. And I think that's the most interesting thing about building interfaces for ourselves. We really get to choose what is meaningful to us in the moment, and that can shift over time, and we're not locked into
Absolutely.
somebody. Yeah, we're not locked into like Apple or Microsoft's assumption about what we value.
Yep. Yep.
I think that's super important. So the other thing that you and I both do, but you have done way more than I have, is build tools for artists. And I could think about, why that's important, but I thought I would ask you, why do you believe making tools for artists matters?
Oh, that's a great question. So I started building tools for artists while I was a PhD student, and Wekinator, as I alluded, it started out as sort of an idea that, I think these machine learning algorithms could be useful in helping artists and musicians make sense of data coming in from sensors, but as soon as I built my first prototype, I was taking it to people who were either students or professionals in those domains and seeing what they wanted to do with it. And I'm really glad that I did that, because that was essential to really realizing what machine learning was useful for. And honestly, it was a lot of fun. And so I keep working that way because it's enjoyable. But really, I mean, the alternative is to have machine learning systems or other technologies that are built by people with computer science PhDs doing the kinds of things that they want to do. And not that those are all bad. There's lots of great ideas that have come from computer science people. Um, However, the type of music, the type of art, the type of games that people make with machine learning is utterly different and so much more interesting than something that I would make if I were just, trying to do all those things as, as an amateur, especially outside of the music space. Like that's not my area. And it's certainly, I think it's silly to imagine that somebody needs to learn how to, become a professional programmer and, become an expert in machine learning and, who knows what else in order to use machine learning in their work. Because even then, the sort of tool set that people have developed for doing, professional data science absolutely doesn't make sense in a real-time context for like making a video game. You actually need a totally different tool set. And again, that's part of why I made Wekinator, because you have to have appropriate tools to give to professional creators and students for them to do the stuff that they might do with it, and you have to work with people to build those tools to understand what the tools have to look like to be of any use at all.
Cool. So this is a moment I would like to go ahead and invite the audience to ask us some questions. So I'm going to just look in the stream and see if we have any cool questions or thoughts. Marie Claire LeBlanc Flanagan pointed out that she really loves the examples you showed, which is a really cool thing. And I see Alan
Thanks.
Zacconi here today, and Ruth and Bruno.
Hi.
So hello, everybody.
Hi.
Hey. And it's good to see all our friends. Some of you I've seen at other points or on Twitter. So welcome. And I would like to invite anyone now to ask any questions they have about machine learning, society, bias, data, all of this. We're here for you. So AMA within reason. While we're waiting to see if anyone asks questions, maybe you and I could just chit chat a little bit about what we're working on now, our project InteractML. So do you want to tell them about InteractML or should I?
Why don't you go ahead? I've been talking a lot.
Sure. InteractML is this really cool Unity open source plugin that Rebecca and I have been working on with Ruth and Bruno, who are actually in the chat today. And it is a way to do gestural control interfaces inside Unity, which is native to a kind of build system. And the reason that matters is when I first started working with Wekinator, I was piping it via Open Sound Control into Unity and then letting that control game spaces inside Unity. And it was really super frustrating for me to not be able to release any of my games or any of my titles because I was stuck to a external, you know, system that couldn't be packaged up. So what Wekinator lets us do is use interactive machine learning to do things like create gestures for game interfaces. Like Rebecca was saying, if you make a fist, your character jumps. Isabel's example is a really good one. In Unity, you could draw a spell with a Vive controller, and that could trigger some game mechanics. All of that could happen real time in the engine now. And you can train those gestures live, and developers can make those gestures available and make training those gestures available to their players, which I think is really powerful and exciting. So that's what Wekinator is and what we've been working on. Rebecca, what have you found really challenging and fun about working on the project?
I mean, the really fun thing for me, as always, is working with you, working with Carlos, working with the other designers on the project to think about, what is different in a games context, what is different in a Unity specific context. How do we make something that is better than Wekinator that might underneath have a lot of the same algorithms, but that speaks the same language, so to say, as a Unity developer or a Unity designer. How do we communicate to our users what the space of interaction possibilities is? Because this is a space that's so unfamiliar to people still. And what we want is for people to take this tool and run with it and do 100 things that you and I haven't thought of.
So Alan has a cool question. His question is, what would you like to see people do with Wekinator outside the fields that they've been working with it in? Exactly, he says. Is there any other field in which you would like to see the Wekinator being used?
Ooh, that's a good question. I mean, it's hard to answer because people have done a lot of really weird stuff with it already. I feel like gestural control is such a fun space to work with. In sound, what I like is that you get this as you play with an instrument that you've built, you start learning about this mapping and you start associating sounds with ways of moving. And I think it would be super cool if we were, I imagine hooking this up to like a recipe generator, and as you move it like gives you slightly different recipes for like chocolate chip cookies, or you explore the space of like
Yes.
weird desserts, or for that matter, I've had a couple students do projects where as you move you're changing 3D parametric design. And I just think it'd be super cool if you could be like, hook it up to like architecture, parametric architectural software, and as you move, you see the space in like a VR space totally change around you. So yeah, that kind of stuff I think would be super fun.
Cool. All right, everybody. Thank you for coming to yet another CCI live stream event for our master's degree program and for the CCI. Rebecca, thank you for joining us today.
Thank you, Fina.
And a big shout out to our technical team who helped make this stream possible, and Georgina and Connor who've been helping online. And other than that, it's been great. And I'll see you all later. Bye.
Bye. Thanks, everyone.